I'm CK, and tonight we're going to do the third and I think the last of the modules in Erica Synths educational series. I've done their oscillator and their envelope generator. Just links to those videos are in the description below. And tonight we've got the VCA. This is the mkixes.edu series. So it's going to be short and sweet because these are generally simple modules, but very instructive. Hope you enjoy the video. So here's the box. It's their VCA. Oh, but first I want to talk about the build guide is more than a build guide for these three units. It's a very comprehensive and very practical introduction and guide to electronics that go into a synth. And I think that the gentleman who wrote this has done an excellent job of giving you a solid grounding without a lot of extraneous stuff that I find many YouTube people add when they're talking about circuitry. This is really straightforward and really understandable about how electronic circuits, particularly circuits involved in synthesis and electronic musical instruments, works. So even if you weren't to buy this module, I would say go to Erica Synths website, look these kits up, and download the user manuals, and you'll find that you've gained a lot of really valuable insight into and information into how synths work. So let's open the box. Power cable, and again, I have a disagreement with this power cable, as you may be able to tell, or maybe not, because it's so light. The red stripe is not a red stripe. It's a line and a dot and a line and a dot, and it's really kind of hard to see. Hold on a second. If you look at a standard eurorack ribbon cable or a ribbon cable, you'll see the red stripe is very distinctive. This red stripe is very hard to see. Now, that's not a huge problem, but think about if you're switching modules on stage or in a club and it's kind of dark, you're not going to be able to see that very well. Even in your home studio, if you're inside a case or in the back of your rack trying to see that, that's not really good. I would certainly wish that they would create or use ribbon cables that have a much more distinctive red stripe. Let's look at the circuit board and the front panel, because that tells us pretty much. Oh, first we get the box ready for recycling. One thing I have appreciated about all three of these modules is they pack all the components in one bag. They don't have individual Ziploc bag for each component set, which drives me crazy because it's so much waste. Okay, so this is a dual VCA. In one, control voltage 1, out 1, and the offset for the initial voltage. And in 2, control voltage, and out 2. So 2 VCAs in one, which is nice. Let's look at the board. This is version 2.0, schematic by Moritz Klein, PCB by Angus Petrus from Erica Synths. Now, as we look at the board, all the components are, kinda. All the components have their values listed, so you don't necessarily need a build guide for this. The only problem is I can tell that we've got 1, 2, 3, 4, 5, 6, 7, 8 stand-up resistors. 8, 9, 10, 11, 12, 13, 14. stand-up resistors, and I don't like stand-up resistors. We'll deal, 15, 16, 17, 18, 19 stand-up resistors. Oh, that's way too many stand-up resistors. In fact, they only have a few lay flat. I don't like stand-up resistors for a variety of reasons, and I'll complain about that in a little bit. But they're also a little harder to see what values go where with stand-up resistors. Got two 072 op amps, power connector, couple of big electrolytic caps, some diodes, one diode, two diodes, looks like just two diodes. Oh, here's three more stand-up resistors. Golly, guys, it does make the board smaller. I'm not going to disagree with that, but I have other issues with it. A bunch of buffering, what I call buffering capacitors, two trimmers, and that's about it. And on the front side, we of course have 1, 2, 3 jacks, a potentiometer, 1, 2, 3 jacks, and a potentiometer. The board is good quality, all through-hole plated. They didn't smooth off the break points. When you get PCBs, they'll come like 8 or 10 or 12 to a large sheet, and you snap them apart, and there are little ridges here at the snap apart place, and they didn't smooth them out, and I don't like that. So I'll take a little bit of 400 grit sandpaper and smooth those off. Issue. So that's the circuit board in the front panel. Goes over there. Let's look at the main bag of bits. Got resistors, which I'll set out because I'm going to be doing those first, and I'll lay them out in the order of how many of each there are. And we've got the two diodes I referenced earlier, the op amps and their sockets, one transistor, two transistors, three transistors. Let me make sure these are all the same. Yeah, they're all 548s. Two trimmers, 100K and 100K. They're both 100K, so that's easy. The electrolytics should be 47s, yep. 47s, 50 volts, and they're both the same. And then a bunch of 104s, I'm going to assume. Yep, 104 tenth of a microfarad capacitors for buffering power around the ICs. And then in here, got the mechanical bits. The mechanical bits are the power connector, two pots, linear pots, jacks, and that's it. So it's going to be pretty straightforward to get it together, except again for all the stand-up transistors, but I'll just grit my teeth and do that. So I'll get the soldering iron heated up and we'll get this started. I'm going to deviate from my normal procedure a little bit tonight because since there are so many stand-up resistors, I'm not going to do them first. I normally do all the resistors first because they lie flat on the board and then you build from low to high to high. but since there are so many stand-ups, I'm going to do those after I do some of the other components. I'll put the 10 ohm resistors on, the 2 Schottky diodes, the IC sockets, and then I'll move on to doing all the resistors. The next step is when you look at a board from a new manufacturer or a new someone you haven't worked with before, you want to take a look and see how wide the parts are spaced. So when you're bending leads, you're going to get the component flat on the board. Some PCB layout software makes the pitch very tight, so you bend the leads right next to the resistor body. Some takes a couple of millimeters, maybe 1/8 of an inch of leg sticking out to the sides before you go through. And different people use different things. This one is a little bit in the middle. Bafaco, for example, uses very, very tight spacing because they cram a lot of stuff on their boards. So you bring the leads right up next to the resistor body, but you get the hang of that. So there's the two 10 ohm transistors. Now I need the 2 Schottky diodes, which go next to the 2 resistors because they're all part of power conditioning and protection. So as you can see on this PCB, for the diodes there's a little line where they go, indicating that's where you put that line, because as we know, diodes are polarity sensitive since they only allow current to pass in one direction. So if you put them in backwards, the current you expect to see going through your kit doesn't get to go through, and then nothing happens, and then you're sad. Which, by the way, is one of the first troubleshooting steps you always, or I always take when something doesn't work right, is I always check the diodes just to make sure I didn't screw it up. Now, because they lie flat also, I'm going to put the 2 8-pin sockets on the board. Sockets have notches just like the chip and just like the silk screen. Now the way I put sockets on, I'll show you 2 ways. First is I support the socket with my ring finger on the back, and I solder one leg, let the solder cool, pick the board up, look at it, make sure it's all flat and down on the board correctly, and this one is, but if it's not, I'll press it firmly with my forefinger, heat that one leg I built up, soldered up before, you'll feel it snap up to the board, let it cool, and you're all set. The other thing you can do, and I generally do this for larger IC sockets, 24, 48 pins, whatever, is, oh, by the way, this notch is on this side, this notch is on the outside, so just be aware of that. So take your socket, put it on the board, get a pair of locking tweezers, which I strongly recommend you have. I have a video about tweezers that I'll link to in the description. And now that the tweezers are holding the socket in place, it's not going anywhere. You can waggle it around, you can do whatever you need to do. And again, I'm going to do the same thing. I'm going to solder one leg. And I'm going to take the tweezer off and take a look, and that looks all wonderful. So I'm going to solder all the pins on the sockets. So So the sockets are down. Now that's all I'm going to pre-do before I do the resistors, because now I'll do all the stand-up resistors. And I am not, as I mentioned, the silk screening values on the board don't work really well for stand-up resistors. So in the user manual, there's a good diagram showing you what values go where. So I'll be using that instead of trying to figure out from the rather confusing silk screening what goes where. Now it's resistor time, and there's not much. Oh, I will talk about this a little bit, sorry. So let me grab the 100K resistors first. I'm going to kind of do this a little differently than I usually do. So how do you do a stand-up resistor versus that? So you take your resistor and you bend one lead over like so, and you find the hole, and that's a 100K goes in here. And then you solder up as normal. Now I will tell you and describe why I don't particularly care for stand-up resistors. They're used often to save space, as on this board, or as a fix to a design issue and you didn't have space, or your circuit layout is whatever and you have to just throw a resistor in. But while they stand up and maybe nothing's ever going to happen to them, they can also be pushed over, and I have seen them short against other components. So I have a real problem with stand-up resistors for that reason. But be that as it may, that's all I want to talk about for resistors. So we're going to have resistor time now. I'm going to stop talking for a little bit and have the playback sped up so you'll just see resistors flying onto the board. And that's all the resistors. As you can see, they're all standing up. One thing I do want to point out is, as you do this on the board, and I'm going to try and zoom in a little bit to give you a better view of that. On the board, there are a number of test points, like labeled D, C, D, B, A, ground. I only point this out because you don't want to get confused. You don't want to put a resistor lead into a test point. So just be careful whenever you're building a board, but this one in particular, many boards, the test points are significantly smaller than the regular solder pads, but these are the same size as the standard solder pads. So just be careful and don't put a resistor lead into a test point, or else the unit is not going to work. Now we're going to do the transistors, and as I'm looking, there are 4 of them. They go 1, 2, 3, 4. And you can see the flat sides correspond to the flat side on the transistor, of course. And this board layout software has the middle lead, usually the gate, going forward. In other words, towards the flat side, where more typically the layout will be the middle leg goes towards the round side. However, it doesn't make any difference. Just be aware when before you splay your leads out, check and say, oh, okay, they want them to go forward, not backwards. And the flat sides are facing each other on these transistors. And one other thing I did want to mention, and this is really aimed more at folks who haven't done a lot of solder work yet, so you don't have your own habits yet. Somebody did ask why I never use a circuit board holder. Well, I do. I have them. I have two of them. I don't like either of them, but that's not the main reason why I don't use them. The main reason why I don't use them is for a board of this size, I find it much easier to just put it on my little silicone rubber solder aid, which I got from Austin Ribbon Mics, and there'll be a link in the description to where you could purchase it if you want, because then I can maneuver things quickly. I'm not constantly moving the board around, flipping it around in the solder in a circuit board holder. That's one reason. The other reason is you really don't, I will use that circuit board holder for, say, an eyelet board for an amp or a big circuit board, but for smaller ones like these, I don't. And the other reason is you don't really need it. And I want to emphasize that part of the reason why I don't need one is because you're not applying any force. Your soldering iron and the solder should not be pressing on the board. They should be touching the leads. They should be touching the leads to conduct heat, but the board shouldn't move because of that. If the board's moving when you're soldering, you're applying too much force. So if you're not applying any force, or very minimal force, just enough to transfer heat from the soldering iron to the component lead, then you don't need to clamp or grip tightly the circuit board you're working on, because it's not going to go anywhere. It's not being pushed around. So those are the two reasons why for circuit boards of this size in particular, I don't use a circuit board holder. Let me trim this all off. Transistors are on. Now we'll do all the 1/10 of microfarad capacitors, the somewhat ubiquitous 104s, these little guys. Now, if you ever wonder, when you're doing a board with integrated circuits, like these op amps on this board, and you can't figure out where some of these 104s go, a good place to look is right around your integrated circuits, because these capacitors are used as what I'll call buffers for the power going into the IC to create a little bank of power to smooth out any dips in voltage or any peaks in voltage, and that often happens very close to the integrated circuit to reduce other wire noise, inductance, and other side effects of having too long a wire run. So I found, I'm still missing one. Where does this last one go? It's interesting. There are only 6, so let me count this again. 1, 2, 3, 4, 5, 6. So they packed an extra one. That happens. Now we'll put the two trimmers on, and again they're the same. And they've got little adjusting screws on top, and on the printed circuit board there's a symbol that shows you where the screw goes. Next we'll put the two electrolytic caps on, and they use the convention of having the square solder pad being for the positive lead, and they also have a stripe on the silk screen showing you where the stripe on the electrolytic needs to go. And one final thing we'll do on this side of the board is put the power connector in, and as per convention, the red stripe on the power connector is the negative 12 volts, and as you can see on the PCB there's a mark saying negative 12 is down here. That means that power connector goes there. And again, same drill as for an IC socket or a pin header or whatever. Solder one pin, take a look, make sure it's all flat and flush, and it is. So we'll solder the rest of the pins and use this last 10, 20, 30 millimeters of solder to do that. Because if you build as many pieces of electronics as I do, you tend to try and use every millimeter of solder you can. Throwing solder out is a bad idea. This also comes from when I was a kid and I didn't have much money, and solder costs money. So that's the front of the board. That's the component side of the board, rather. Now, one thing I'm going to do before we move on is I'm going to take an index card and I'm going to go line by line down the board and look at all the solder joints to make sure there's no bridging, there's no shorting, to make sure all the leads have actually been soldered. And I use index card like this to reveal just one row at a time, so my eyes aren't looking at 100 solder points at one time. They're just looking at 6, 7, 8 of them. And they all look good. So next we'll be putting the mechanical components on. But not right now, because I gotta go feed the cats. Let's put the mechanical bits on. Now I'm going to do it this way. I'm going to take two jacks. Here's one jack. And I'm going to solder one of the pins down. I'll make sure it's flat, and it is. I'm going to take a jack at the opposite end. Try and get the pins in. Come on, pins. And solder that pin in. I don't think this one's quite flat, so let me see what happens. Oh no, that went in completely flat. Now I'm going to put the pots on, and since it's two VCAs, the pots are both the same. We put the rest of the jacks in. Now all the components are on, so we'll take the front panel and drop it down, make sure everything gets snugged in. Now, the two jacks I soldered, one leg on, I will take a panel nut and snug the panel nut down just finger tight. And what that does is keeps the board together, keeps everything spaced correctly, so everything is ready to solder. One thing you'll probably notice is there are no LEDs on this product, so you don't have to worry about positioning LEDs. So that's all the soldering that we're going to do on this board, so I'm going to turn the iron off. Now I'm going to put the two ICs, two dual op amps, which are just as the name implies these are little amplifiers. Now the notch is there, and on these chips from TI they don't have a notch on the chip, they have a little dot that takes the place of the notch for orienting what you're trying to do. What I'm trying to do is get the pins lined up. There we go. That's one. Straighten the legs out a little bit on the edge of my workbench. And again, remember that the notches point opposite directions on each VCA. Okay, all the chips are in, clicked in nicely. All pins are in, no pins are bent. Next thing I'll do is put the power cord in. And that's it. Except for panel nuts. Let me do those real quickly. Okay, all done. Knobs turn well. This is the front, the side, the back, the other side, top and bottom. Let's go put it in the rack and see how it works. Let's hear how it sounds. We're going into a Midi Thing to a Bufaco ADSR that's feeding into the VCA, and we're using an even VCO from Bufaco. So let's do some simple stuff. Works just fine, as you'd expect. Let me adjust the attack. Take out the release. So, as you can tell, it's just a VCA, nothing particularly outrageous. If I turn up the voltage offset, then of course it pre-triggers raising the voltage floor. Now one thing that is interesting, because it's a dual VCA, is if you have CV hooked into the first VCA, it's triggering both the first VCA and the second VCA. Now if I unplug that and plug it in down here, it works of course, but the top one doesn't. So let me try and make this more reasonable. So with the top one plugged in and nothing plugged in for CV on the bottom one, it echoes to both, which is very convenient. Now, if you have something plugged in to the bottom one, and I don't have another envelope out here, sorry, so I can't tell. You can see, I'm sorry, you can't see because I'm pressing the keys, but I'm pressing the keys on my keyboard, and because there's a CV input plugged in, even though it doesn't have any voltage on it, it's still not triggering that. So that's interesting. Now, one thing I didn't check was whether the voltage offset changes. Oh yeah. So I can have one VCA with the voltage offset set and one VCA set to a different voltage offset, or none, which can be useful if you have, if you're working with something that's a little oddball voltage-wise. So there it is. It's a good beginner kit. Again, the manual that comes with this is so good that you should go download it from Erica Synths website, even if you're not going to build this. It's got so much good practical information that if you're a beginner or even intermediate, you should read through it, learn some really pragmatic ways of approaching electronics and approaching electronic musical instruments. So that's the three. This is the third of the three in the Edu series, all just dandy. And this one is nice because it's a dual. Be very handy long term. Hope you enjoyed the video.